Okay, so let me share my screen. Okay, so I think we are good to go. So this is the second sheet that we are doing. So the first problem is determine whether each function is a solution to the differential equation and justify your answer. So this is the differential equation given to us, and we have to check whether these are the solutions of this differential equation or not. So like, for example, if I'm picking the first one, y is equal to 4x cubed, then I need to find the value of the derivative because I need the value of y in its first derivative only. So the derivative by using power rule is going to be 12x squared. If you plug these two values here, the equation is y times dy by dx is equal to 6x squared. The value of y is 4x cubed. The value of the derivative is 12x squared. And the right hand side is 6x squared. Just I need to verify that whether left hand side is equal to right hand side or not. So this is going to be like when you multiply these coefficients, 48, and you add these exponents. This is 5, which is obviously not equal to 6x squared. So y is equal to 4x cubed is not a solution. Okay. So similarly, you can check whether number 2 is a solution or not, whether number 3 is a solution or not. Okay. So let's move to the next question. This question is asking find the particular solution to a differential equation whose general solution and initial condition are given, and C is the constant that we need to determine. So if you pick maybe the first one, the simplest problem is like you are given that x of 0 is equal to 5. It means 8t is equal to 0. The value of x is 5. And you need to put these values into this differential equation, like the solution of the differential equation, which is the general solution. So you need to put here t is equal to 0 and x is equal to 5. So x is equal to 5 and t is equal to 0. So e to the 0 is 1 and c times 1 is c. So the value of c is 5. So the solution is x of t is equal to 5 e to the 3t. Okay, so this is like when you find the value of this constant, you get a particular solution. And similarly, you can do other questions as well. Like we can do fourth one too here, if you like. So it says that the value of t is 2 and the value of q is 4. We need to put these here. So the general solution is 1 over ct plus c. So the value of q that I'm going to put is 4 and the value of t is 2. So this is 2c plus c. So this is going to be 1 over 3c. And if you know, like, yeah, so what am I doing? I'm multiplying 3c on both sides. So this will be 3c times 4 is equal to 1. And this will be 12c is equal to 1. I'm dividing by 12 on both sides. So the value of c is 1 over 12. Hence, the particular solution is 1 over, I need to put the value here. C is 1 over 12. 1 over 12t plus 1 over 12. If you like, you can simplify this thing, but like no need to do this. Okay, so this is the value of C. Okay, so this is the actual problem where you are given these separable differential equations and you have to solve these equations. Like you can pick any problem, you separate the variables, and then you integrate, then you find the constant of integration that you have in your problem. Okay, so maybe I'm picking this one, number 3. Sorry. So number 3, dy by dx is equal to 1 plus y squared times cosine x. So step one is we separate the variables. So for this one, I'm going to multiply dx on both sides first. So dy is equal to 1 plus y square cosine x dx. And then I'm dividing 1 plus y square on both sides. So I can get rid of this. I have dy over 1 plus y square is equal to cosine x dx. And the second step is I'm going to integrate. This is step 2. So it's like integral dy over 1 plus y square is equal to integral cosine x dx. So you should know the integral of this type of function. And if you remember, this is tan inverse of y is equal to the integral of cosine is sine, because the derivative of sine is cosine, plus constant of integration. So this is my solution. I'm going to call it 1. And now the initial condition that you can see is this one, y of 0 is equal to 0. So now step 3 is you find the value of this constant. So y of 0 is equal to 0 means what? Means at x is equal to 0, the value of y is equal to 0. So you put these two values into this first equation. So tan inverse y is 0, sine of 0 plus c. Tan inverse of 0 is 0, sine of 0 is 0, and I have plus c. So you can see it means the value of c is 0. If you put this value back into this equation, the solution that you will get is tan inverse y is equal to sine of x. Okay, so this is the solution for problem 3, and for all other problems you need to follow these steps. Step 1 you separate, step 2 you integrate, and step 3 you find the value of the constant. But in this case the value of the constant is 0. It may or may not be 0. Okay, so let's go ahead. I have this question about, like you can see here, this equation, this is about Newton's law of cooling or warming. So, and also problem number 5 is similar to this. So what am I doing is I'm doing this problem 5, and you will get an idea how to do problem 4. So the question is, an object has a temperature 400 at time 0. It is placed in a room with 20 degrees Celsius temperature. So obviously, now you can understand we have to follow the Newton's law of cooling or warming. So for Newton's law, you need to remember the differential equation, Newton's law of cooling or heating. The differential equation is dH by dt is equal to negative kh minus the temperature of the surrounding medium, which is 20. You can see 20 degrees Celsius in the room. Now this is a differential equation that we need to solve. And we have solved this differential equation many times. And if you want to write the solution now, the solution will look like h is equal to 20 plus some constant e to the kt. But like you can always find the solution. So if you want to write the solution directly, it doesn't matter. You can write this one, but it's all up to you. So I need to multiply dt on both sides. So this is going to be negative k. So this is negative k, sorry. H minus 20, but negative k, positive k does depend upon that. If the temperature is 400, then it's going to be 20. Sorry, the room temperature is 20. Obviously, it will decrease. So this negative k should be good. Then I'm dividing h minus 20 on both sides. This is now this quantity, negative k dt. And now I can integrate. The integral of left is natural log of h minus 20. The integral of right is negative kt plus c. Now if you apply exponential on both sides, this is like exponential kills the logarithmic term. You have h minus 20 is equal to e to the negative kt plus c, that you can write in this way, times e to the c. And e to the c, you can replace this with some constant a. So h minus 20 is equal to a e to the negative kt. And if you add 20 on both sides, plus e to the negative kt. So this is the solution, but I need to determine what's the value of a and what's the value of k. And you can see this is exactly what I wrote before, the same solution. So I need to determine what's the value of a and what's the value of k. So you can read this problem and see that, okay, time is equal to 0, the temperature is 400. So you can use this thing here, at t is equal to 0, the temperature is 400. If you plug these values here, h is equal to 400 is equal to 20 plus a e to the negative k times 0. So if I subtract 20 on both sides, this is going to be 380, and e to the 0 is 1, so this is the value of a. You can put this value back here, so h is equal to 20 plus 380 e to the negative k t, and then you can read the problem. After 2 hours, the object is 50. So obviously you can say this is the new equation, but at t is equal to 2, the temperature is 50. So you can incorporate this information here. The temperature is 50 is equal to 20 plus 380 e to the negative k time is equal to 2. Now you have to solve this equation for k. That will give you the value of k. So if you subtract 20 on both sides, this will be 30. 380 e to the negative 2k. You divide 380 on both sides. This is 30 over 380. Whose zeros I can cancel. If you take the log on both sides, negative 2k is equal to log 3 over 38. And you divide this minus 2, then you will get minus 1 over 2 log 3 over 38. And you need to find its value from some calculator, and you put it here. Now if you compare this guy with this one, L plus A e to the kt, h is equal to L plus A e to the kt, then the value of L is 20, the value of A is 380, and the value of k is this whole value along with the negative sign. So this whole value with the negative sign will be, this sign will be positive. So in this way, like, you just read the question and try to answer the questions that are being asked, like what's the value of A, what's the value of L, and what's the value of K. Okay, so this is problem 5, and if you read problem 4, it is very similar to this one. Okay, so problem 6 is about find all equilibrium solutions. For equilibrium solutions, you said just derivative equal to 0, you will get all those equilibrium solutions. And draw the slope field and use it to determine whether the equilibrium solution is stable or unstable. We'll not be doing any drawing of the slope field on our final exam, so you may exclude this thing. And this is a very big problem, so also if you want, we can skip this problem. But we have to understand how to do problem 7. Because for this differential equation or any of this differential equation, we are given an equilibrium solution. We need to determine whether that equilibrium solution is stable or not. So how to do this is this. So if you are picking, let's say the second one. So dy by dx is equal to 20 minus y. So y is equal to 20 is an equilibrium solution. Like if you put y is equal to 20, 20 minus 20, this guy becomes 0. Hence the derivative is 0. But we need to determine whether these whether this y is equal to 20 is stable or not. So you know the tricks. So for example, this is the grid, and this is the solution y is equal to 20, this one. Now you pick anything that is bigger than 20, say 21. If you put this in differential equation here, 20 minus 21 is -1, which is negative, or which is less than 0. It means if you start with 21, let's say, you should decrease. This is what this condition says. And this is case number 1. And case number 2 is if you start with less than 90, less than 20, say y is equal to 19, then the derivative is 20 minus 19, which is 1, which is greater than 0. So if you are starting at any number which is less than 20, for example, 19 here, you should always increase. So you can see these solutions are converging this one, so the solution is stable, okay? And it is coming from the convergence. Okay. Maybe the last problem, we don't need to draw the slope field. We don't need to do any difficult things. We have to just, like, we have already done this in class, but I might ask you this question or similar question on your final exam. So you should have an understanding how to do this. Okay. So we have to pick the point which is 0, 1. So x is 0, y is 1. Let's say this one. And then we have to draw the solution. Draw the solution. Obviously, here it will be a non-zero solution, which is y is equal to 1. Sorry, it's a zero solution, not zero solution. What should I say? It's a constant solution. Sorry. Then 0 to -1. -1 is somewhere here. So your solution might look like this. You should go down. And from here, you should go down. And 0, 0 is origin. And at origin, you can again see the solution looks like this. The solution looks like this. Okay, this is not the right depiction, it can go a little bit off this one. Yeah, that's not the right depiction, so you cannot decide, okay, whether it is 100% correct or not. So this was problem 8. Just to practice on these all the problems, try to understand what am I doing. Then you will be good to go with your final exams. Okay, so see you.